Hi everyone, I'm Sindhuja. I'm from branch ECA and today I'm going to talk about the basic timer in microprocessor and microcontroller, and my roll number is 23401A04A7. The introduction. A timer is one of the most important hardware components in these systems. It helps in measuring time uh, intervals, counting events, and or to generate the delays. Timers works based on the clock pulses. It helps in measuring time intervals from the system clock or from an external source. There are essential in performing real-time operations such as event counting, and generating the signals like PWM, which we can use for controlling motors or LEDs. Each timer has some important parts like registers, control bits, prescalers to adjust the timing accuracy depending on the task. It can operate timer mode where it counts internal clock pulses, or counter mode where it counts the external pulses. Purpose of the timers. The main purpose of the timers is to handle time based task automatically. They are used to generate the accurate delays for executing specific program instructions, to count the external events coming from sensors, or to measure the durations between the two signals. Timers can also trigger interrupts at regular intervals and produce the periodic waveforms such as square waves or PWM signals. In embedded systems, timer helps to schedule real-time tasks like sampling data, switching between different processes. They also help in controlling devices like LEDs, buzzers, or in detecting signal timing such as frequency or pulse width. Types of timers. There are different types of timers available in controllers. Timer counter 0 is a basic timer used for the simple delay generating or counting external pulses. It can work in either time or counter mode and is usually 8-bit or 16-bit. Timer count is more advanced timer, generally 16-bit that can supports wider range and higher accuracy. It can also use it for the baud rate generation in serial communication systems like UART. And next we have that timer or counter 1. Timer or which provides the external uh, timer or counter 2, which provides the external extra features such as capture or compare or PWM functionalities. It's used in applications like motor speed control, waveform generation, and frequency measurements. And finally, the watchdog timer, which acts like a safety guard if the system stops responding or the programs get stuck. The watchdog timer automatically resets the microcontroller. This ensures the reliability in critical or industry systems. Let us know the working principle for the basic timer. The working principle of the timer is simple. It counts clock pulses based on the predefined value. Once it reaches that value, it can trigger an interrupt or set a flag. By configuring the resistors and control bits, we can define how long the delay should last or how often event should repeat. The time delay is determined by T is equals to prescaler into max count plus 1 by F suffix clock. And let us take example in the 8051 microcontroller. There are two 16-bit timers, timer 0 and timer 1. Each can work either as a timer or an counter, as it control T mode and T con registers. These timers operates in four modes, from mode 0 to mode 3, which we define the time behaves like how many bits it uses or whether it shares functions with other registers. Uh, Next, the applications. Timers have a wide range of applications. They help in generating accurate delays, counting the external events, producing PWM signals for motor or LED control, and measuring the frequencies on pulse widths. Timer are also used in real-time clocks, alarm systems, and task scheduling in embedded systems. Let us know the advantages of timer. Provides precise timing and event control, reduces CPO workload through the interrupt based operation, can be combined with the interrupts and counters for flexible control, and essential uh, for embedded system designs and automation. And finally, the conclusion is the basic timer in MPMC is a crucial hardware feature that allows microprocessor and microcontroller to perform various time independent operations with high accuracy. Timers are used in almost every microcontroller based application for synchronization, optimization, measurement, making them one of the most indispensable components in modern electronic system design. Thank you.